Right, so now we're going to do an introduction on algebra. Algebra is just really the same thing as we've been doing in all other sorts of maths. Adding, subtracting, multiplying and dividing. Now we've got letters involved. Before I go into algebra, I'd like to do a quick summary of what we're doing when we take numbers. For example, if we were to add 6 and 6 and 6 and 6 and 6 5 times. We could write it like that, but we know it's much easier to write it like this. 6 times 5. 5 lots of 6 is what I have. Okay? So I could write it like this, or I could write it like this. The addition sum sign here means that we're taking the sum of. Okay? The sum of lots of things means we're adding up all of those things together. Whereas the multiply sign here tells us that we're taking the product of. So the word product means multiply. The word sum means adding. And we can use exactly the same thing here if we had letters instead. So if we were to have A plus A plus A plus A plus A, we could write it like that. But if I've got 30 different lots of A's, it's going to take me a long time. So it's much more sensible to write it as 5 lots of A. This is the sum of A. These are the products of A. But in maths, we don't usually bother putting that multiply sign there. We would just write that as 5A. So this is the product of all of the numbers of A's. But the word 5A actually means the A added to itself 5 times. So 5A is exactly the same as A plus A plus A plus A plus A. What is this letter A then? Well, it can be any number. It could be 0, it could be 999, it could be minus 15. It has lots of different values. So we call the name of the letter A, we call it a variable because the value varies. And it's exactly the same word in Swedish. So you need to know these terms, sum of, product of, variable. How would I represent then A times A? Well, it's a product because it's got the times in between. But A, anything multiplied it by itself, has this very important form here. There's 2 lots of A multiplied by themselves. We can present that in potential form. Okay? A squared. A squared. So this one here is in now potential form. What would I do if I had A times A squared? Well, we know that from our powers of last year when we worked with exponential form, that what does A times A squared mean? Well, it actually means A times A times A, because A squared is the same as A times A. So we would get A to the power of 3. Okay, so A times A times A is exactly the same as A cubed. And these are in potential form then, raised to the powers of. So A raised to the power of 3. So let's use some of these skills to look at how we'd solve some of these questions then. This one's pretty easy. We've got A and we've got it how many times? 1, 2, 3, 4, 5. So we'd represent this as 5 lots of A. We wouldn't bother with the times sign. We'd just write it as 5A. And it means 5 lots of A added to one another. A times A would be represented as A squared. We'd represent it in potential form, A squared. What do we do when we've got a lot of string then of lots of different numbers? Well, we try and simplify them by putting all the letters that are together. Think of them as being apples and bananas. So if we were going to add apples and bananas, we'd look at how many apples do we have? Well, we have 3 A's here, 3 apples, and Fiona came along and ate 2 of them. Okay? So how many apples would we have where we'd have 3 minus 2 that Fiona ate? We'd have 1 apple left. And we can actually think of, when we're doing addition and subtraction, we can think of a figure. If that helps you think of apples instead of thinking of A's, then use that in the start because it can make it easier. So first thing I do is just identify, where do I have A? Here I have 3 A's. The most important thing about my next set of A's is looking at the sign in front of it. There's a minus sign there. So don't forget to subtract the 2A. Don't add them. Then we would look here, we have a B and we have a 2B. That means we've got 1 banana and we're adding 2 more bananas. So how many more would we end up with? We'd end up with 3. Okay? So if we were to put this and simplify this whole expression, we first add up our A's, we get 1A. And when we add up all our B's, we get 3 B's. So what do we do here? Exactly the same thing. We try and identify where our A's are. And I always think it's helpful to underline them in different colours to make sure that I haven't missed any. Okay, now I've got 3A minus 2A, which is A. And it's easy when it's a string like this with only 4, but sometimes you've got strings with 12 different sets of letters that you've got to add and subtract to one another. So 3A minus 2A would give me 1A again. 2B minus 4B. So we've got 2B and we're taking 2 away. 4 minus 2 would be 2 B's, but the biggest number has a minus sign in front of it, so the answer has a minus sign in front of it. Remember, the way of working out minus, when you've got a larger number that's minus, take the small number from the largest number anyway, and then take the sign that was in front of the largest number. So 4 minus 2 is 2, but there's a minus sign in front of the large number, so there's a minus sign in front of the answer. A minus 2B. Then we have the next one, we've got a little bit more letters. Let's identify our A's first. We have 3A here, and we have 2A here, and we've got no more A's. So this would equal 3A plus 2A would give us 3 plus 2 is 5, so 3A plus 2A would be 5A. 2B plus C, no, plus another B. Now we're looking for B's. Here's 2B and here's another B. So how many B's do we have together? 2 plus 1 is 3, so we would have 3 B's. And then C minus 2C. So our C's are here. We've got 1 C and we take 2 C's away. How many would we end up? We'd end up with a minus C. And this is much easier than writing it like this. A plus A plus A plus A plus A plus B plus B plus B minus C. This means exactly the same as this. This is a really ineffective way of writing, and mathematicians are lazy, okay? So we do it the simplest way. 5A plus 3B minus C. And we can't simplify that anymore, because these are totally different numbers. A, B and C are totally different variables. This could have a value of 1 in one question. That could have a value of 15. This could have a value of minus 30. You don't know anything, so you've got to keep them as separate terms until you're told more about what value does A or B or C have. Then we have the expression here. What about A multiplied by A squared then? Well, A times A squared, you have to remember that A means actually A to the power of 1. And if you remember your skills from when we were working with scientific notation, the way that we work out powers that are multiplied by each other is we actually add them. 1 plus 2. So A to the power of 1 multiplied A to the power of 2 is A to the power of 1 plus 2, which is A cubed. We know that because A times A squared is really A times, and A squared means 2 A's after one another multiplied. And that equals A cubed. But this is using the skill that we learned at the beginning of the year. How to do when we are multiplying terms with different powers. A to the power of 1 plus 2 giving us A cubed. What do we do then when we've got different letters that are multiplied by each other? Well, if we have something like this now, we have 2 lots of A multiplied by 3 lots of B. If it had been 2A times 3A, it would have been really easy because it's the same letter. We'd have written it as 2 times 3 is 6, A times A is A squared. But A squared is actually A times A. So if it's different letters, we actually do the same thing, but we can't put in the square sign. 2 times 3 is 6. A times B in maths terms is written as AB. We forget all the times signs and just write it as AB. That means A multiplied by B. So 2A times 3B is written as 6AB. What do we do then if we have 2A times 4A? Well, we multiply the numbers together first as though it's a normal multiplication. We do 2 times 4 is 8. And then we do A times A, and we know that A multiplied by another A will give us A squared. So the answer to this one is just 8A squared. And it can be simplified, and whenever it can be simplified, you should simplify it. Then we have, what about when we have division then? Well, we know that if we've got 1 divided by 1, we're going to get the answer 1. 100 divided by 100 is going to give us the answer 1. 50 divided by 50 is going to give us the answer 1. Minus 2 divided by minus 2 is going to give us the answer 1. There's a minus up here and a minus down there, so we still have exactly the same number divided by itself. We're always going to get 1. Whether it's a negative number or a positive number, if we have divided the same number by itself, we're always going to get the answer 1. So if we have A divided by A, we're still going to get the answer 1, because any number divided by itself gives us the answer 1. So here we have a division where we have our dividing line here, and our answer is our quotient, which is almost the same word in Swedish. Okay, so remember that when we've done. And we know that we have the top number in English is called the numerator, and in Swedish it's called that. And the bottom number is our denominator, which you call that in Swedish. Okay? Remember all these basics of division. Remember the quotient. That's when one number is divided by another. Okay, what do we do then when we've got something like this? If we have 2 times A times B divided by 4A, how do we simplify that then? Well, we know that A divided by A is actually 1. So they can just cancel. So when we've got terms that are multiplied by each other like this and divided as well, A divided by A will give us 1. So what will that give us left? Well, it will give us 2B divided by 4. But 2/4, that's a fraction that can be simplified. We can divide top and bottom here by 2. So we're never allowed to leave it in the term 2/4. We'd have to simplify that as well by saying 2 divided by 2 is 1. So we'd get B divided by 2. 4 divided by 2 is 2. So you must always change it to its simplest fraction form. So this expression that looked quite complicated actually simplifies out to a half of B. Or B divided by 2, which you can write as a half of B, or you can write as 0.5 of B. And all of those things mean the same thing, in fraction form or in decimal form. Right, that was that one. What do we do then when we've got something like this, when we've got adding and dividing on the same one? Well, if we have 8A plus 6A divided by 2 lots of A, there's 2 different ways of doing this. I can see that I have a in all of these terms, so I could just cancel it out and get it to say 8 plus 6 divided by 2. I can only do that if there is an a here and here and here. So it has to be an a in every term. Why can I do that? Well, think about it as being simplified, that we take out the a outside of the front of this term and we put in brackets, which is what we were talking about last week. If I was to take a out the front, what would I get inside the bracket? Well, 8 plus 6 is what I'd get inside the bracket. Why? Because a times 8 would give me 8a, and a times plus 6 would give me plus 6a. So these two expressions mean exactly the same thing. But my original question had that the whole thing here was divided by 2a. So that's what I have to do. Now I can say, well, a is up there and down here, so they cancel. And I know that 8 plus 6 is 14. So I get that it equals 14 divided by 2, which equals 7, which is what I would have got here. 8 plus 6 is 14. 14 divided by 2 equals 7. So this complicated looking expression actually just ended up to give you a real number. Instead of a variable, we now had an answer. That the answer to 8a plus 6a divided by 2a is 7. And this is one of the things that they really want you to look out for. It's when you can convert a variable expression with lots of a's into a real number. Okay, let's look at another one then. What can we do with this expression where we have 1.099 plus 1.099 plus 1.099 divided by 1.099 plus 1.099. I'm changing it here. Well, if you don't have a calculator, you might think that looks quite complicated. Let's exchange 1.099 with a. So what have we got on the top here? We've got a plus a plus a divided by a plus a. So on the top we have 3 lots of a, and on the bottom we have 2 lots of a. So the number a, the letter a, actually cancels, and we get equals 1.5. So if you get a question like this on the calculator paper, dividing by 2.198 is really quite complicated without a calculator. But if you keep it in terms of, and change it in terms of algebra expression, then it's really, really quite easy. The answer would be 1.5. So the answer to this must equal 1.5. Because if it had been a there, we know that it was that simple. We'd have got a real answer. So you'll get a real answer there as well. The answer will be the same, 1.5. I've seen this type of question on lots and lots of little tests, and in the national test as well, and in all the little quizzes. People want to understand if you understand this concept. And it wouldn't matter if we'd have done, let's say that we'd have done 15 1.09s. divided by 3 1.09s on the bottom. We'd have got 15a divided by 3a, which would have been 5a. So the answer would have still been 15 divided by 3 would have been 5. Not 5a, 5. The answer would have been 5. Okay, what about when we've got a's and b's then up here? What can we do to simplify those? Well, again, in the top one, we can take a out of the front of the brackets. So we get a times bracket equals a times 3 would give us 3a, plus sign in the middle here. A times 2b would give us 2ab. So I've now taken the a out of the front of the brackets and turned this expression, the top line here, into a times 3 plus 2b. You have to get used to simplifying with brackets like that, all divided by 2 lots of a. Now I have a divided by a, which I know is 1. So my answer to this equation, the way I can simplify it most would be that it's 3 plus 2b all divided by 2. Which I'd leave it in that expression. You could change that to 1.5 plus b but I'd probably leave it in that form. Okay? They both mean the same thing. 3 divided by 2 is 1.5. 2b divided by 2 is just 1b. 2 divided by 2 is 1. So you can leave it in either of those forms. So that's just the basics of algebra. Understanding what to do when it's multiplication, understanding what to do when it's addition, understanding how to put brackets in, and how to simplify. And that should help me with the first 5-10 pages of the algebra chapter.